In this video, we are going to learn how to calculate angular acceleration of an object which is in circular motion. The question says, you are holding the axle of a bicycle wheel with a radius of 35 centimeter and mass 1 kilogram. You get the wheel spinning at a rate of 75.0 revolution per minute and then stop it by pressing the tire against the pavement. You notice that it takes 1.20 seconds for the wheel to come to a complete stop. What is the angular acceleration of the wheel? So if you sketch the problem, you have a wheel that is spinning at the rate of 75 revolution per minute. Now revolution per minute is the unit of frequency. So this value 75 RPM is the value of your frequency F. 75 revolution per minute. You can convert revolution per minute to revolution per second by dividing this value by 60, and you get the value in revolution per second as 1.25 RPS. RPM means revolution per minute and RPS is revolution per second. Now, if you have the frequency, you can calculate the angular velocity of the object at that point using the frequency. The relationship between angular velocity and frequency is omega equals 2 pi f. And since this is the initial value of my velocity, I will write this as omega initial. So we can get omega initial by multiplying the frequency with 2 pi f. Then the question says radius of the bicycle wheel is 35 centimeter. I can write my R as 35 centimeter. You can convert this to meter by dividing with 100. So you get 0.35 meter. And you stop it by pressing it against the pavement. And you notice that it takes 1.20 seconds for the wheel to come to a stop. Now when the wheel comes to a stop, its velocity at that point will be 0. So this is my final angular velocity. And since it comes to a stop, the final angular velocity will be 0. 0 radian per seconds. And it takes 1.20 seconds to come to a stop. Question wants me to find what is the angular acceleration alpha. Now the rule for calculating alpha is angular acceleration alpha is equal to change in angular velocity over the time. Change in angular velocity can be written as final angular velocity minus initial angular velocity over the time taken. My final value is 0. Initial you can get by multiplying 2 pi with the frequency f over the time interval. So now let's substitute the value. Negative 2 pi. Frequency is 1.25 revolution per second. Divide by the time, which is 1.20. And when you solve this, you get your angular acceleration as negative 6.54 radian per second squared. This is my value of alpha.